Okay. Topic 4, chemistry, periodic, whatever. This is topic 4, carbon. Okay. Yeah, let's start. Graphite and diamond are allotropes. What does that mean? What is an allotrope? They're chemicals that come from the same element, but they come from the same element. Allotropes are different structures of the same element. Yeah, so but they have different structures. Okay, so same element, same physical state. But what do you need to know? They're different structures. Take a look at diamond and graphite. They're allotropes of each other. Look, they both come from carbon. However, they have different shapes, as you can, different structures, as you can see. I think question 2 is also coming. Yes. So you should know. This is a nice summary. I think it's also in the notes as well. Over here, carbon is compounds. I think they did like a nice. Yeah. So they have the over here, as you can see. You can go over the notes if you want. But over here, this is a nice table to compare between the two. Diamond, you need to know it's what tetrahedral, but graphite is triangle. Okay, it doesn't say triangle, but how I remember it, and I use triangle to remember that it's connected to 3. That's how I remember that it's connected to 3. I say triangle, because look over here, each one is connected one here, one here, one here. So if you join the 3 carbons it's connected to, it forms a triangle. That's how I like to remember it. And it was actually in the notes that it forms a triangle. So if she asks it, what shape does it form? Remember triangle for graphite. But diamond, it's a tetrahedral. You need to know each carbon in diamond is connected to 4. You need to know it's strong. Okay, in graphite, each carbon is connected to 3. And then each plate is bounded to another. I don't know, what do they call them? Plates? They call it a layer. Layer. Yeah, each layer is connected to another layer by van der Waals. Okay, so that's why, by the way, graphite is a bit weaker than diamond, because of the presence of van der Waals bonds. Remember, we said that VDW bonds, VDW van der Waals, they're weak. Okay, they're very weak bonds. So if you have VDW, that means they're weak. Not weak, but you're weaker than the one that doesn't have VDW. So let's read over them. Diamond is a tetrahedral. Each carbon is strong to 4 other carbons, and there are no free electrons. You should know that, right? Since it's bonded to 4, carbon needs 4 to be complete. Okay, it has 4 free electrons. When it bonds to 4 other carbons, that means khalas, it gave away all its 4 ones. Here in graphite, since we're bonding to only 3, that means since carbon has 4, right? Since we're bonding to 3, and I'm talking here. Since we're bonding to 3, carbon only gave away 3 of its 4 electrons, so it's gonna have 1 free one. That way it leaves 1 free electron unbounded. Okay, this forms a cloud of electron, whatever. There are weak forces of attraction between the layers. What are they? VDW. Anytime you see weak forces of attraction, that means they're referring to VDW, by the way. Okay, that is why graphite is actually soft and slippery. You can see here. Here they're saying hexagons. Hexagons because of the shape like this, as you can see here. Okay, if they say what is the shape, triangle should work, because it was here. Wait. Okay, خلاص. Just say linked hexagons. Okay, just say linked hexagons. If they ask you about the shape of the graphite molecule, it's a structure of linked what? Hexagons. Okay. Moving on, question 3. List major uses for each graphite and diamond. This also comes as well. Graphite, you need to memorize this. Okay, graphite for furnace lining. Why? For everything there should be an explanation. Okay. For furnace lining, why would you put something in a furnace? Because it has a high melting point, right? Electrodes, because it doesn't react. You guys know graphite doesn't react, and it's an electrical conductor, right? Or no, forget about doesn't react. If you want to use something in an electrode, it should conduct electricity. Common sense. Lubricants, why would you use something as a lube? Slippery. And pencils, because it's also slippery and soft. Okay, you need to memorize these because they come. I remember it came matching. I think matching or multiple choice. But this came in a CA before. Diamond, you should know, obviously, in jewelry and glass cutters. Abrasive materials is just anything that's hard, I think. What's an abrasive material? Okay, an abrasive material is just a hard material used to wear with, like, kind of like this paper that you rub something on it, you know what I mean? Okay, anyways, memorize. So, furnace lining, electrode, lubricants, pencils, and then for diamond is jewelry, glass cutter, rock boards, and abrasive materials. Graphite is soft and conducts electricity, while diamond is hard and does not conduct electricity. Explain. Obviously, if something conducts electricity, the first reason for conducting electricity means there is a free electron somewhere. Okay, you need to mention free electrons. Yeah, let's see. Wow. Graphite is a layered structure of repeated hexagons, where every carbon atom is strong. Okay, I think they're asking for both the conducting and the soft hard part. Why is graphite soft? Let's see. It's soft because of the van der Waals forces. Okay, that's why they're soft. So let's take a look. Graphite is a layered structure of hexagons where every carbon is strongly bonded to 3, leaving 1 electron free. That forms the free electrons. making it a conductor. So this explains the conduction. If I were to mark you on this, honestly, I wouldn't write all this. I'd say graphite is made out of layers where each carbon atom is bonded, say strongly bonded, to 3 other carbon atoms, okay, leaving one free electron that forms a cloud of free electrons, which makes it a good conductor. This is, if you just include this, yani carbon bonded to 3 other carbons, that's the main one, and then you have to say it leaves one free electron, okay, which leaves a cloud of free electrons. That means it conducts electricity, okay? Remember, conducts electricity, free electrons. Let's take a look at diamond. Why doesn't it conduct electricity? Because it's bonded, carbon is bonded strongly to 4 other carbons, leaving no more free electrons, okay? So it does not conduct electricity, okay? And then let's talk about the strength. Since graphite is aligned with weak van der Waals forces connecting the layers, what does that mean? It's soft. That's pretty much it. Okay, they didn't ask about slippery, but you can mention this. Okay, make sure you read everything, guys. Gain as much knowledge as you can. There's never a limit to how much you can memorize. Why is diamond hard? Because the carbon bonds are strong, so the diamond is hard. Remember, each carbon is covalently bonded to 4 other carbons. Strong. How do you test for CO2? So if you want to, by the way, just memorize, okay, this table over here. This table, this is important, okay? Remember, diamond tetrahedral. Carbon strongly bonded to 4 other. Here, graphite, hexagonal shape, okay? Each carbon bonded to 3, leaving 1 electron, okay? These are like things you should remember. How do you test for CO2 and state will be observed if excess CO2 is used? I can see this coming in earthen, although we do have past papers in the material. I would see it coming in earthen. So, how do you test for CO2? We all know we use lime water, right? So pass it through lime water, but the key word here is for a short time, because if you keep it for a long time, what's going to happen? Let's just take a look. When a small amount of CO2, it turns milky or cloudy, right? Due to the formation, you need to know this, okay? One of these could all be questions. Why does it turn cloudy? Because it forms the precipitate CaCO3, and CaCO3 in water becomes cloudy. Okay, so as you can see here, calcium hydroxide is lime water. Lime water is calcium hydroxide, huh? Plus carbon dioxide to produce CaCO3 and H2O. Okay, as you can see. If you use excess CO2, the turbidity disappears as soluble calcium hydrogen carbonate forms. So you get this instead of this. Okay, but this is soluble. Okay, so you need to know if it's excess. You should know if it's excess, it won't be milky. Okay, if this comes multiple, if this comes written, whatever. Okay, you should know this important note. Calcium hydrogen carbonate is always aqueous and never a solid, so it's always dissolves. Okay, let's take a look. Question 10. What do we have? 10. I have 10 to 12. With 7. What is photosynthesis and respiration? What's produced in each process is very simple. I'll go over it fast. Photosynthesis is where the plant manufactures its own food, right? What does it do? It absorbs carbon dioxide from the air and water from the soil. And what does it produce? Oxygen and glucose, right? But it has to be in the presence of sunlight energy and chlorophyll. I think khalas. Everybody at this stage in grade 11S should know what photosynthesis is. Respiration is the process that any organism on Earth produces energy by burning food. It's burning one glucose in the presence of oxygen to produce carbon dioxide and water plus energy. Okay, these are reverse reactions of each other, by the way. Okay, silicon oxide and carbon dioxide have similar formulae but different types of structure. Okay, silicon oxide, remember silicon oxide is SiO2. Carbon dioxide is CO2. The first part is to write the formula. Let's take a look. I think it's SiO2 and CO2. Let's take a look. Yeah, SiO2 and CO2. Okay, what do we know about SiO2? We know SiO2 is a network solid, right? So obviously the structure would be different since SiO2 is a giant structure when carbon dioxide is just one molecule. Let's take a look at the answer key. I want to see how they said. SiO2 is a giant molecule since it's a network solid, right? While CO2 is a simple molecular structure made of molecules. So that's exactly what I said. Part C, why do diamond and silicon oxide have common properties? What do we know about diamond and silicon oxide? What's common in them? We know that they're both network solids. We know that they're both strong giant structures. So due to their, okay, what's common about them? We know they both have a tetrahedral structure, right? This was in chapter 9, if you haven't seen it already. Due to they both have a tetrahedral structure where they are strong covalent bonds, so they are both hard. اتفقنا انه silicon dioxide, remember chapter 9, اتفقنا we agreed that silicon dioxide and diamond are both hard materials. وكمان we agreed that what's it called? We agreed that they both don't conduct electricity. Okay, so that's why they both have no free electrons, so they are both non-conductors. And we also agreed that it's a tetrahedral. They're both tetrahedrals. What will be observed when HCl is added to Na2CO3? Write an equation for the reaction state symbols are necessary. طيب, let's take a look. What are we looking at here? Try and understand what you're adding. Don't just add things. Take a look. Maybe it's a reaction you studied before. HCl, we know hydrochloric acid is an acid. Na2CO3 is a metal carbonate. What happens when we add an acid plus metal carbonate? Don't we get salt plus water plus carbon dioxide gas, right? Remember this from salt preparation chapter 3. So let's write this down. HCl aqueous, they said state symbols, plus Na2CO3 sodium carbonate aqueous as well. To produce the salt is going to be NaCl, obviously. NaCl, which is aqueous, it dissolves, right? Plus water H2O, which is obviously a liquid, plus the gas, which is carbon dioxide. Let's see if we need to balance. No balancing. Ambala. H2O. You need to put a 2 here and put a 2 here. It's balanced like this. Okay, let's take a look. Yeah, exactly like this. Okay, and they said what is observed, right? What will be observed? Whenever you have a gas being produced, what do you say? Effervescence, right? Remember this from chapter 3. So since we have a gas being produced, you say effervescence. And try and add as much as you can. They also said a colorless gas is released. It's not really an observation. If it's colorless, how can you see it? But خلاص, just say it, colorless gas released. طيب. Let's take a look at part B. What will be observed when a small amount of carbon dioxide gas is added into lime water? Write an equation. We know that the lime water will turn milky white. Why, guys? Why does it turn milky white? Because of the production of CaCO3, calcium carbonate, which is insoluble, right? So a white precipitate is observed according to the following equation. So you have to say, no, it will turn milky white due to the formation of calcium carbonate. Okay, that will be correct. And they said write an equation. Let's do it without looking at the answer. Carbon dioxide is CO2. Lime water, we said it's calcium hydroxide.
That's it.
To produce, we said calcium carbonate, and I think it was water. Is this balanced? Yes, I think yes.
Yeah.
Yes, it is. Let me see. State symbols. State symbols, obviously carbon dioxide gas. Calcium hydroxide should be a liquid. CaCO3 it's a precipitate, so it should be a solid, and this is a liquid. Let's take a look. Calcium hydroxide is aqueous. Okay, interesting. Yeah, I think I understand why it's aqueous. Just keep it aqueous. You need to know these reactions really in case they come. I feel like there's too many questions about this lime water turning milky, so I really feel like you should expect it in your exam. Okay, just take a look at the reaction. Minimum is that you're not able to memorize, or you're not able to memorize a reaction. Just remember it turns milky white. That's the bare minimum, seriously. Okay. Question شو بعد فيه؟ we're done. Okay, nice. Okay, that was very short. 17, 18. Okay. Okay, perfect. Thank you so much for watching, and good luck.